So if you want to take a random sample and use the sample mean x bar to make inference about a population mean mu to do a t-test, it's very similar to what we did for a z-test. If you were doing it, let's say you were going through and completely doing it by hand, you'd take your sample. Of course, if you were completely doing it, you would have to find your sample mean and your sample standard deviation, and then you have your sample size, and you have some hypothesis about mu, and you take that, the null hypothesis, you take that value and you compute your test statistic, which is measuring your difference from the, it's kind of measuring how extreme your sample mean is compared to your population mean from your hypothesis, measured in standard deviations using s over square root of n. So you would compute your test statistic t, which is x bar minus mu, all divided by s over square root of n. And then you would have to find the probability from that particular distribution using n minus 1 degrees of freedom, and based on the direction of your alternate hypothesis, whether it's a less than, greater than, or a not equal to, whether you're doing a one-sided or a two-sided test, you'd find the area under the curve, similar to the way that we did for z procedures, and that would give you your p-value, and you would make your decision based on that. Okay? And there's tables that list these using degrees of freedom to help you find the appropriate values, and we can also use technology, and I'm going to use the TI-84 here to do an example in a minute. We can also do confidence intervals. Again, it looks very similar to the formula and the discussion for z intervals. So the idea being you're going to take random sample and you want to try to make an interval that you're C% confident that the actual mean is in there. Okay, so the process that does these, C% of the time you would get a confidence interval that actually contains it if you thought about taking all possible random samples. So that's your confidence level. And your interval winds up being centered around the sample mean. They're always your statistic plus or minus your margin of error. So it's x bar plus or minus our margin of error is t star s over square root of n. So that's, again, our approximation of the standard deviation for x bar, s over square root of n, the sample standard deviation divided by square root of the sample size. And t star, similar to the z star that you use for a z interval, that's your critical value that traps C% of the population between t star and negative t star on the t distribution that has n minus 1 degrees of freedom. And so that'll give you your interval. And some advice on when to use this interval. Of course, you have to have random sampling, and you want your population to be approximately normal, or again, to kick in the central limit theorem, you want fairly large samples. Since we're also approximating the sigma using s, we're going to say you probably want about 40 or more for your sample size. And you want your population to be large, again, to get the independence. Here I say 20 times as large, which again, it might vary from person to person or book to book on the suggestion, but you want your population to be a lot larger than your sample. Okay, so those critical values, they could be looked up in tables, or we can find it on, I did something very similar to find z star when I did notes on that. So the t star, you can actually find negative t star by doing inverse t on your calculator, and the area would be one of the two tails that you have there, so it would be 1 minus c divided by 2. If you have c in the middle, you have 1 minus c in the tails, and you split that in 2. And so you do inverse t on that area, and the command on the TI-84, 83 calculator is to do the area and then the degrees of freedom. Okay. And then that would give you negative t star, so I say to do the negative of that, which would give you the positive value. Okay. So, and that's in the same menu as inverse norm that we use if we do that for the z procedures.